Hello. The k-nearest neighbor algorithm is what we will discuss today. It is a very simple classifier. These category of classifiers are based on learning by analogy. At this video, the contents have been taken mainly from this book by 𝑛𝑒𝑒𝑎𝑟𝑒𝑠𝑡. So these classifiers, they classify by comparing a given test tuple with training tuples that are similar to it. Okay. So they will do the classification by comparing the unknown test tuple with similar tuples. So let us suppose the training tuples are described by n attributes. That means they are having n features or in the n dimensions. For example, this is a small data set of 5 points, and we can see that each tuple is defined by two values. So which means our n equal to 2. Now, the working of this classifier, for an unknown tuple, the k nearest neighbor or KNN classifier searches the pattern space for k training tuples k. See, this is the k is a value, natural number, for the k training tuples that are closest to the unknown tuple. And for this classification, the unknown tuple is assigned the most common class. That means by majority vote. And in cases where k equal to 1, the unknown tuple is assigned the class of the training tuple. Because k is 1, so only one similar tuple we have found. So the same class is assigned to this. So we take an same example where the unknown tuple is given as 2, 2. And to find these k nearest neighbors, let us compute all the distances of this tuple with the given 5 points. These distance proximity measures we have earlier discussed, and I have given the link of the playlist for data handling and proximity measures. So now we will find all the distances. So this is an example. We are taking the Manhattan distance or the city block distance. So this tuple 2, 2, when we compute its distance from 1, 1, then we can see that this value is coming from 2 minus 1, absolute value plus 2 minus 1. So this is how we get this value 2. This is the Manhattan distance computation. For the next, it is 2, 1. So there is no difference in the first variable and one value here. So we get the value of 1. And similarly, we compute all the distances of this tuple 2, 2 with x1, x2, x3, x4, x5. Also note that we have now included the labels of each of the training data tuple. Now so we have the distances. When we want only one nearest neighbor, k equal to 1, so we will look at the smallest distance, k equal to 1. For k equal to 1, the smallest distance here happens to be value 1. So which is the tuple x2, x2. And what? So we have said that the k nearest neighbor set is x2. For k equal to 3, the set is, so we now look at the distances in the ascending order. So we have distance 1, x2 we have taken. Then the next higher distance is 2, which is of x1. So we include x1, x2 smallest, this is 2. And again, the distance 2 we obtain also from training tuple x3. So this is x3. So the k nearest neighbors for k equal to 1 and k equal to 3 we have found. Now we go on for the classification. So for the recall, I've written this down. For the k nearest neighbor classification, the unknown tuple is assigned the most common class among its k nearest neighbors, and for 1, it is given the tuple, the label of the closest training tuple. So for when the nearest tuple is x2, its label is n. So we have written n. And for 3, x2, x1, x3, the label is the majority of the 3 labels. So we see for x2, so this n is straight away assigned to the new tuple xt. For this, when we k equal to 3, x2, x1, x3, so we have x2, x1, x3. So 2n and 1y, so majority goes to n. Okay, so for k equal to 1, the label is n, and for k equal to 3 also, the label is n. And we can see that if we had taken k equal to 5, because we had only 5 data points, all 5 would go into the closest neighbor set. And here we are having 3 y's and 2 n's, so the label would be y. So for the same tuple, as k changes, the label may change. For k equal to 1 and 3, it was same, but for 5, we got it as y. So having seen the classification done by the KNN algorithm or the k nearest neighbor classifier, we also note that it can be used for numeric prediction. That is to return a real valued prediction for a given unknown tuple. So suppose we have x1, x2, x3, x4, x5, and the target variable now has values like 3, 7, 15, say 20, and maybe 16. And we say that the KNN for a tuple is x2, x4, x5. So what will this KNN algorithm do? It will give the average value of the labels. So x2, x4, s5, we have 7 and 20 and 16. So this is 43 divided by 3. Average of these values would be given. So KNN algorithm can be used for classification and prediction, real valued prediction as well. There is one point to be noted that since we are assigning equal weights to each attribute, so this may have poor accuracy in case of noisy or irrelevant attributes. Okay, till now we have seen that when we take the average, it is the simple average. So then what is to be done? We modify the method by weighting and pruning of noisy data tuples. So these are some variations which people have designed so that KNN can be used even in case of irrelevant or noisy attributes. So I hope you have an idea of the k-nearest algorithm, and thank you for watching. Thanks.